Okay guys, in today's lesson we're going to do some practice on free response questions that involve the fundamental theorem of calculus and particle motion. So in this first question we see that the function f is differentiable on the closed interval from -6 to 5 and satisfies the initial condition that f of -2 is equal to 7. That is going to be important later on in this question. Okay, and then we're also given the graph of f prime, which we notice right here. In part A, the question is wanting us to find the values of f of -6 and f of 5. So f of -6 is going to equal to, I have to start from a given initial condition of f of x. And so that is my f of -2 is equal to 7. So I'm going to write down f of -2, and then I'm going to add the integral of f prime of x dx, and that's going to be from my given initial condition, which was x equals -2, until the x value that I'm wanting to find, which would be -6. So this will equal to f of -2, which is 7, and then the area that they're talking about under the graph of f prime from -2 to 6 is going to be this area under the triangle. And this area is going to be negative because we are integrating from -2 until -6. That is backwards, and so even though that region is above the axis, I'm going to subtract its area. So this is going to be -1/2 the base of that triangle, which is 4, multiplied by the height of that triangle, which is 2. And if I go ahead and calculate that number, then I end up with 3. For f of 5, this is going to be the exact same thing. I have to start with the given initial condition, f of -2, and then I'm going to add the integral from that given x value until the x value that I'm wanting to find of f prime of x dx. And so this is going to end up being 7. The first area is going to be from -2 to 2, so that's going to be this little half circle here that's below the axis. So let me use my highlighter. That works a little bit better than the pen does. So this little half circle that is below the axis, we're integrating in the correct direction, and so that means I'm going to subtract the area of that half circle, which will be 1/2 of pi times the radius squared. The radius of that circle is 2. And then we're going to add the area of the next piece, which is this triangle. And the reason we're adding, once again, is because we're integrating in the correct direction, and that triangle is above the axis. So this will be +1/2 times the base, which is 3, multiplied by the height, which is 2. And if we go ahead and calculate that number, that would be 10 minus 2 pi. Okay, on part B, we're wanting to find the intervals on which f is increasing. And so I remember that f increasing means that f prime is positive. And so that would occur on 2 different intervals on this particular graph. That would be from -6 until -2, and then also from 2 until 5. And so I'm going to write down my intervals first, -6 to -2, union 2 to 5. And my reasoning is very simple. It's because f prime of x is positive, and that's really all that we need to say there in order to justify our answer. On part C, we want to find the absolute minimum of f on the closed interval from -6 to 5, and so this is going to be what we call a candidates test. My candidates are the endpoints, -6 and 5, so I'm going to do my candidates test over here, plugging back into f of x. So my endpoints, -6 and +5. And then my other candidates are going to be the critical points. And the critical points occur whenever f prime of x is equal to 0. And this occurs at x equals, if we take a look at the graph, it would be when x is equal to -2 and +2. And so I'm going to write that as my critical points, -2 and 2. And this will be on my candidates test chart as well. Now, the beautiful thing about this problem is that we've already done 2 of these, and then one of them was given to us. f of -2 was given to us in the problem, and then f of -6 and f of 5 were calculated in part A. So we can just import those answers here into part C. The only thing that we need to find is f of 2. So f of 2 is going to equal, I'm going to do this very similar to the way that I did f of negative 5 and f of negative 6 and f of 5 in part A. So this will be the integral from f of f prime of x. The given value is negative 2, and the one that we want now is 2. And so this is going to equal to 7 minus the area under f prime from negative 2 to 2. And so that's going to be my little half circle here that's below the axis. And so that will have an area of 2 pi. And so f of 2 is going to be 7 minus 2 pi. And then a quick scan of my y values and a look at which one is the smallest one. The smallest one would be 7 minus 2 pi. And so I'm going to write my answer in a sentence form and say that the absolute min of f is 7 minus 2 pi, and it occurs at x is equal to positive 2. Okay, on part D, we want to find f double prime of negative 5 and f double prime of 3, or state and explain why they do not exist. So I'm going to start with f double prime of negative 5. Remember that f double prime would represent the slope of f prime, and we are given the graph of f prime in the problem. And so all we really need to do is find the slope of the graph at x equals to negative 5. And if I want to find the slope at negative 5, it basically comes down to finding the slope of this line segment right here. And so if I take a look, what's going to end up happening here is to find the slope, I want to figure out how many I'm going down. And so I am going down 2 points. And so that would be a rise of negative 2. And then I'm moving over to get to the next point, 1, 2, 3, 4 points. And so my run would be 4, and that would give me a value of negative 1/2. For f double prime of 3, what I notice is that on this graph of f prime at x equals 3, there is a sharp turn. And so what that tells me is that the second derivative of f at 3 does not exist. And I could say sharp turn if I wanted to, but I'm going to use a little bit of a more rigorous reason for why the slope at 3 does not exist on f prime. I'm going to say that the limit as x approaches 3 from the left of f prime of x minus f prime of 3 over x minus 3. This represents the slope from the left side of 3. I'm going to say that this does not equal to the limit as x approaches 3 from the right of f prime of x minus f prime of 3 over x minus 3. So sharp turn would work here, but it wouldn't be as rigorous or as good as the answer that we've written out here. This would be sort of the answer that would be most acceptable on this particular type of question whenever you have a sharp turn. Okay, on example 2, this is a calculator active question, so you should get your calculator out and prepare to use it. We're going to use it on all 4 parts of this question. So we are given that a particle is moving along the x-axis. We are not given the particle's position function, but we are given the particle's velocity function and the particle's acceleration function. And in addition to that, we are given an initial position when time is equal to 0. So we're given x of 0 is equal to 2. The first thing that you need to do on this problem is pick up your calculator and type these 2 functions in to your y equals screen so that you can use them throughout this problem. So in part A, we want to know, is the speed of the particle increasing or decreasing when time is equal to 5.5? And so in order to do this, we're going to compare the signs of the velocity at 5.5 and the acceleration at 5.5. And if I have my calculator handy, then I can just type this into my calculator using alpha trace y1 of 5.5 and alpha trace y2 of 5.5. And when I do that, I get the answers for the velocity to be negative 0.4533, and for the acceleration, I get negative 1.3585. Now, since the velocity and the acceleration are both negative, therefore they have the same signs, what we can say about the speed is that the speed is increasing. So I will say the speed is increasing at t is equal to 5.5, since my reason is because v of 5.5 and a of 5.5 have the same signs. Okay, so make sure you not only say that it's increasing or decreasing, but you also give your reason. And I think it's also important that you give these two values as well from your calculator. So make sure that you write those down on your paper as well whenever answering a question like this. Okay, on the next part of this question, they're asking us to find the average velocity for the particle over the time interval from 0 to 6. And so this goes back to what we talked about in a previous lesson about the average value formula. We use the average value formula whenever we're asked to find the average of a function that we have in our hands. And we have the velocity function in this particular problem. So we're going to use the average value formula. So that's going to be 1 over b minus a, the integral from a to b of the function that we want to find the average of, which would be the velocity. And so typing this into our calculator to get the answer using the Math 9 button, what we would end up with after it takes a second to calculate would be 1.9493. Now, if you were to use the average rate of change formula on this, you would probably do something like this, v of 6 minus v of 0 over 6 minus 0. And this right here would give you what is called the average acceleration. So that's why we don't want to use this formula on this problem. This would be the incorrect way to respond to this. And because we have the velocity function, we're asked to find average velocity. That's why we use the average value formula. Okay, in part C, they're asking us to find the total distance traveled of this particle from t equals 0 until t equals 6. And so what this basically boils down to is, do you have the formula for total distance traveled memorized? If you do, you're probably going to pick up two pretty easy points here. And if you don't have the formula memorized, you're going to miss out on what are two pretty easy points. And so remember that the formula for total distance traveled is the integral from a to b of the absolute value of the velocity. So the integral from 0 to 6 of the absolute value of v of t. This should be done in the calculator, and what you should get is 12.5732. Make sure that you type in the absolute value bars in your calculator, and make sure that you also write down the integral. So this right here is a very important part of your answer. Without this integral on your paper, you're actually going to score 0 out of 2. Even if you have the correct answer, if you don't show where the answer came from in the calculator, you will not receive credit on this question. So it's very important that you write down the formula and then write down the answer that you obtained from the calculator. Okay, part D is probably the most challenging part of this question because you have to read very carefully what it's asking you to do, and then you have to remember some particular concepts about particle motion. And so it says that between 0 and 6, the particle changes direction exactly one time. Find the position of the particle at that time. And so what I'm going to do is focus first of all on when does this particle change direction. And I know that that happens whenever the velocity changes signs. And so I'm going to look on my graph of v of t on the calculator for when does the velocity change signs. And if I use my calculator to do that, I'm going to get t is equal to 5.1955. Okay, so we are looking for the position at 5.1955. Another way to say that would be x of 5.1955. Okay, this is going to equal to, I have to start from some given initial condition of the position. So if you look back at the header of the problem, we notice that we are given an initial condition of the position. X of 0 is equal to 2. So I'm going to start here with x of 0 and then add the integral of the velocity. And my bounds are going to be 0 on the bottom, since that was my given initial condition. And my upper bound will be where I want to find the position, which is 5.1955. Okay, obviously that writing didn't really work out for me right there, so let me just kind of scratch that out and put 5.1955. And then I'm going to calculate this in my calculator using the Math 9 button. So this will be 14.1347. And that is the final answer. Okay, the next problem is also calculator active. It says that the temperature of water in a tub is given by this function W of t, and that W of t is a strictly increasing function. That will become important later on. And in part A, they want us to use the data in the table to estimate W prime of 12. And so W prime of 12 is an instantaneous rate of change of the temperature when time is equal to 12. In order to estimate that number or approximate that number, we're going to use the average rate of change, and we need to pick an appropriate interval for time 12. And so that would be here between 9 and 15. So this is going to equal to, or be approximately equal to, W of 15 minus W of 9 divided by 15 minus 9. And so using the values from the table, I have 67.9 minus 61.8 divided by 6. Now, even though you have a calculator, you could technically leave your answer like that if you really wanted to, or you could go ahead and calculate it and get 1.0166. But before we move on, we need to put some units. And so what I notice is that my numerator is measured in degrees Fahrenheit, and my denominator is measured in minutes. And so the unit for this particular answer is going to be degrees Fahrenheit divided by minute. Now I'm going to answer the second part of this question using correct units, interpret the meaning of this answer in the context of the problem. So remember that a derivative measures the rate of change of a quantity. And so because the derivative of W at 12 was positive, that tells me that W was increasing at time t equals to 12. And so that's going to be what my response is centered around. I'm going to say when t is equal to 12 minutes, the quantity W of t, which measures the temperature, so the temperature of the water, is increasing. And the reason I can say that it's increasing was because my answer for W prime of 12 was positive at a rate of 1.0166 degrees Fahrenheit per minute. Okay, in part B, it wants me to use the data in the table to evaluate the integral from 0 to 20 of W prime of t dt. Whenever we want to find a definite integral, there are really three different ways to do that. The first way is using the Math 9 button on your calculator. In order to use that method, I've got to have a function for W prime of t. And if I look around, I don't have that here. So that's not going to be the way forward on this particular problem. The second way is to use the area under the graph of W prime of t, and I do not have the graph of W prime of t, and so that method is not going to be what we want to use here. The third way is to use the fundamental theorem of calculus and find an antiderivative of W prime of t, and that's something that I can definitely do here. So the integral from 0 to 20 of W prime of t dt is going to equal to the antiderivative of W prime, which is just W of t evaluated from 0 to 20. This notation means that I'm going to plug in my upper bound of 20, subtract, and plug in my lower bound of 0, and those two numbers are going to come from the table. I'll have 71.0 minus 55.0, which you could go ahead and calculate if you wanted to. That would be 16.0 degrees Fahrenheit. Now, in the context of this problem, the meaning of this integral is the change in the temperature. Remember, if I have a rate and I integrate that rate, that's going to give me the change in the amount of that quantity. And so what we can say about this answer is that the temperature of the water increased because the answer was positive, so I can say it increased by 16 degrees Fahrenheit, and I want to mention something about the time interval. So I'm going to say from t equals 0 until t is equal to 20 minutes. Okay, so remember that if you integrate a rate of change, that basically just gives you the change in the amount of that quantity. Okay, in part C, what they want us to do is estimate the average temperature of the water, which is given by this integral right here, using a left Riemann sum with 4 subintervals that are indicated by the data in the table. So I'm going to begin by writing down 1 over 20, the integral from 0 to 20 of w of t dt. And this is going to be approximately, that 1 over 20 needs to make it on the other side of that approximately sign. And then I'm going to open a bracket and do the left Riemann sum part. So for my left Riemann sum, here's my first subinterval. I'm going to use the number that's on the left, and so that would be 55.0. And then I'm going to multiply by the width of that subinterval, which goes from 0 until 4. And so the width of that subinterval would be 4. Plus, if I go to the next subinterval, the number on the left is 57.1. I'm going to multiply by the width of that subinterval, which goes from 4 until 9, so that would be a width of 5. Plus, the next subinterval, the number on the left would be 61.8, multiplied by the width of that subinterval, which is going from 9 until 15, so that would be a width of 6. And then finally, my last subinterval, I will have 67.9 as my y value on the left, multiplied by the width of that subinterval, which is 5. And I know that you have a calculator in your hand for this problem, but it doesn't matter. You can still leave the answer in this unsimplified form, and I highly recommend that you do that because you don't want to make a mistake by accidentally typing in something wrong, and you definitely don't want to waste your time calculating the answer when you don't really have to. Okay, so the second part of the problem begins with this sentence. Does this approximation overestimate or underestimate the average temperature of the water over these 20 minutes? And so what I noticed back up in the header of the problem is they told me that W was an increasing function, and we used a left Riemann sum. So if you recall your acronym, I love you, Drew, then that means that because this is increasing with a left Riemann sum, this is going to be an underestimate. So I'm going to say this underestimates the average temperature. And the reason is because W is an increasing function. So I'm just going to say W is increasing. And I used a left Riemann sum. That's pretty much all I need to say there. I don't need to be any more descriptive than that. Just the fact that W is increasing and we used a left Riemann sum is enough to prove that this was an underestimate. Okay, the final part of this question says that for the interval from 20 to 25, the function W that models the water temperature has a first derivative that is given by this function right here. And then based on the model, what is the temperature of the water when T is equal to 25? So what they're asking me to do is find W of 25. Well, if I'm given the first derivative, I'm obviously going to use that at some point. So I'm going to have the integral of W prime of T dt. But I've also got to have some initial condition or initial value of the temperature of the water. And if I pay close attention to the interval here, the initial condition that I want to use is W of 20. So W of 20 is going to be the initial condition that I use. That's now going to help me figure out what the bounds on my definite integral are going to be. 20 was the given, so that goes on the bottom, and 25 is what we want, and so that is going to go on the top. Okay, from there I'm going to let the calculator do the rest of the work. And so typing this into the calculator, just replacing W of 20 with its value from the table there, I'm going to get the final answer of 73.0431 degrees Fahrenheit. Okay, in our fourth example, we're given the function h defined on the closed interval from -4 to 8, and we're given the graph of g, which consists of 2 linear pieces and a semicircle. And then it tells us that we want to let f be the function defined right here. So in part A, we want to find f of 7 and f prime of 7. So we'll start with f of 7, which means I'm just going to plug 7 into my function for f of x. And so this will say 3 times 7 plus the integral from 0 until 7 of g of t dt. Okay, so this will equal to 21 plus the area under the curve of g of t from 0 until 7. And so that will include this half circle right here from 0 until 6. And then it will include this rectangle from 6 to 7. The circle is going to be negative since we're integrating the correct direction, and that circle is below the axis. So this will be negative 1/2 multiplied by pi of the radius squared, and the radius is 3. And then plus the rectangle, which has a base of 1 and a height of 3. So that would be 3 times 1. And this would be a perfectly acceptable way to leave your answer, or you could go ahead and put 24 minus 9 pi over 2. Either one would be perfectly acceptable. Now for f prime of 7, we're going to need to first of all find f prime of x. And so going back to my function of x, which is back up here, we're going to take the derivative one term at a time. So starting with 3x, the derivative of 3x is going to just be 3, plus the derivative of the integral from 0 to x of g of t dt, that will have to be second fundamental theorem of calculus. So I'm going to take the t that's right here, and I'm going to replace it with the upper bound, which is x. And so this will be g of x multiplied by the derivative of that upper bound x, which of course is just 1. So f prime of 7 is going to equal to 3 plus g of 7. And that's going to equal to 3 plus g of 7 is just the y-coordinate on the graph of g when x is equal to 7. And so that's going to be this point right here. And the y value there, it looks like, is 3. And so this is going to be 3 plus 3, which is equal to 6. Okay, this next part is pretty tricky, so I'm going to do my best to explain exactly what is going on here. We want to find the value of x in the closed interval from -4 to 3 at which f attains its maximum value. And then we want to justify our answer. So in order to figure out anything about the maximum of f, I need to figure out what f prime is. And so f prime of x is going to equal to, from part A, 3 plus g of x. Now, on the interval from -4 to 3, -4 would be here, and then 3 would be here. What I notice is that g of x, which is this term right here, never goes below -3. And since g of x never goes anywhere below -3, that means that f prime of x is always going to be positive on the interval from -4 to 3. No matter what, g of x is never going to be negative enough to make f prime a negative answer. I hope that's making sense. Okay, but 3 plus g of x is always going to be positive because g of x is always going to be bigger than or equal to -3 everywhere on the interval from -4 to positive 3. And so if f prime of x is always greater than or equal to 0, then what this means is that f of x must be what we say non-decreasing. So we'll say non-decreasing for the interval from -4 to 3. And so if that's true, if f of x is non-decreasing from -4 until 3, that means that f of x must be either increasing or staying the same on the interval from -4 to 3. So just over here, I'm going to kind of sketch for you a sort of a picture of what f of x might look like. So let's just say here at -4 that the y value on f is here. And then if it does nothing until it gets to 3, then increase or stay the same, then it might look something like this. And so just that little sketch shows me that the maximum value of f has to occur when x is equal to 3. And so I'm just going to finish off my little statement here and say that therefore the max value of f of x on that closed interval from -4 to 3 must occur at x equals to 3. So I know that might be a little bit confusing for you. If it is, then please feel free to drop me a question in the comment box or whatever, or ask it in class, and I'll be more than happy to try to clarify that for you. On part C, we're asked to calculate a couple of limits. So I'm going to start with the limit as x approaches 0 from the left of g prime of x. And so if I approach 0 from the left on g of x, this is basically just asking me to figure out what is the slope from the left of 0 of g. And so if I look at this using my highlighter here, then basically what I'm going to be finding is what is the slope of this line segment, since that's to the left of 0. And so if I find the slope of that line segment, it looks like I'm going to be going down 2 and over 4. And so the slope there is going to be negative 1/2. For the other limit, as x approaches 0 from the right of g prime of x, well, the right side is this circle. And so the circle, as x approaches 0, what's happening is that slope at 0, as x approaches 0 from the right side, is going to be infinite. And so if that slope is infinite, because it's a vertical tangent line, we say that this limit does not exist due to that vertical tangent line that's coming in from the right of 0, since this is kind of a circle. By the way, over here, you would also have a limit that did not exist. If you were going to take the limit as x approaches 6 from the left, then that would also not exist if you're taking the limit of g prime, which is the slope of g. And then finally, part D is a limit as x goes to negative 2 of f of x plus 7 over e to the 3x plus 6 minus 1. And so what I'm thinking off the bat here is that this is more than likely a L'Hopital's rule problem. And so for L'Hopital's rule, what I have got to do first is show that the limit of the numerator is equal to 0. And so I'm going to say the limit as x goes to negative 2 of f of x plus 7. Well, this is going to be f of negative 2 plus 7. And what I'm going to need to do now is calculate what this f of negative 2 is. So I'm going to do a little bit of scratch work here, just sort of in my mind. Okay, f of negative 2 using this function is going to be 3 times negative 2 plus the integral from 0 to negative 2 of g of t dt. And so that's going to equal to, I'm going to come back over here in blue, negative 6. That was from the part right here, 3 times negative 2. And then this integral part is going to be the area under g of t from 0 until negative 2. And so that's going to be this little triangle right here. That's going to be a negative area since it's above and we're integrating the wrong direction. And it's going to be negative 1/2 of the base 2 times the height 1. And then the plus 7 is just going to come across. And so this is going to equal to, if I go ahead and calculate this, negative 6 minus 1 plus 7, which is equal to 0. I'm now going to calculate the limit as x goes to negative 2 of the denominator. So e to the 3x plus 6 minus 1, that's my denominator. And so that's going to be e to the 3 times negative 2 plus 6 minus 1, which is e to the 0 minus 1, and e to the 0 is 1. And so that limit is also equal to 0. And so what I can now say is, therefore, using L'Hopital's rule, this is going to become the limit as x approaches negative 2 of the derivative of the numerator. So the derivative of the numerator is going to be f prime of x divided by the derivative of the denominator. And the derivative of my e to the 3x plus 6, I'm going to use the rule for that, which says e to the 3x plus 6 times the derivative of 3x plus 6, which is 3, and then the derivative of minus 1 would just be 0 since it's a constant. Okay, I'm going to go ahead and try this again. So f prime of negative 2 divided by 3 times e to the 0. And now I need to figure out what f prime of negative 2 is. Well, remember from part A that f prime was equal to 3 plus g of x. And so this is going to be 3 plus g of negative 2 over 3. And g of negative 2 is the y value right here. Let me use my little laser pointer so you can see that. that's going to be positive 1. So this is going to become 3 plus 1 divided by 3, which will give us our final answer of 4/3. Okay, I hope you guys are feeling a little bit more comfortable answering some free response questions on fundamental theorem and motion. And if you guys have any questions, then please feel free to ask me.